So far, we have discussed the two main factors that influence pump performance when a pump is either running or shut down: static head and pressure head. Now we will examine two factors that affect a pump's performance only when the pump is running: velocity head and friction head. Velocity head. When a pump takes liquid from a stationary status and creates flow, it imparts velocity in the fluid, seen as kinetic energy. The velocity in meters per second can be converted to equivalent head in meters using the following formula. Velocity head in meters equals the square of the velocity in meters per second divided by the product of 2 times g. While static heads and pressure heads are present when a pump is shut down or running, velocity head is only present when a pump is moving liquid. It should be noted that because a liquid is not compressible, the same volume of liquid entering the pump has to leave it. Since suction lines are larger in diameter than pump discharge lines, the velocity in the pump suction line is smaller than the velocity in the discharge line. Example 1. If a pump has a suction velocity of 4.8 meters per second and a discharge velocity of 12.5 meters per second, what is the suction and discharge velocity heads? Here's our example. Our pump has a suction velocity of 4.8 meters per second and a discharge velocity of 12.5 meters per second. What is the suction and discharge velocity head? For the suction side, velocity head in meters equals the velocity squared divided by 2 times g. Velocity head equals 4.8 meters per second squared divided by 2 times 9.81 meters per second squared. Velocity head works out to 1.17 meters. For the discharge side of the pump, velocity head equals the velocity squared divided by 2 times g. Velocity head equals 12.5 meters per second squared divided by 2 times 9.81 meters per second squared. Velocity head equals 8.0 meters. Friction head. As the liquid flows through a pumping system, friction in the pipe and fittings acts as a resistance to fluid movement. This resistance causes a pressure drop in the system. Pressure drop in a piping system caused by friction due to moving liquid is called friction head and is measured in equivalent meters of head. Because friction head is caused by liquid movement, like velocity head, it has a different value on the suction and discharge sides of the pump. The magnitude of friction head in meters depends on the following factors. 1. The length of the pipe in the system. The longer the pipe length, the greater the friction head. 2. Pipe diameter. The smaller the pipe diameter, the greater the friction head. 3. Liquid flow in meters per second. The greater the flow, the greater the friction head. And 4. The number and type of fittings in the system all work to increase the friction head. Friction head is measured in meters of head for 25 meter sections of pipe length. Table 1 below tabulates the friction head for 25 meters of pipe length for different diameters and flow rates of Schedule 40 steel pipe. Table 2 gives values of equivalent pipe length of various fittings for different diameters of Schedule 40 steel piping. Let's first look at Table 2. Table 2 gives us the length of straight pipe of the same diameter that would have the exact friction head as a certain fitting. This is called the equivalent pipe length of the fitting. For example, Table 2 tells us that for a 101.6 millimeter diameter pipe, a standard elbow, which is one of 90 degrees, would have the same friction head as 3.35 meters of 101.6 millimeter straight pipe. And we can see here, if we go down to the pipe size and we go over to the standard elbow size, which is 3.35 meters of pipe length for every standard 90-degree elbow. Okay, adding the equivalent pipe lengths of all fittings to the actual pipe length gives us the total equivalent pipe length for the system. Table 1. Table 1 gives us the friction head loss for every 25 meters of pipe length for a certain diameter and flow rate. So, if we have a diameter of 101.6 millimeters for a flow rate of 25 liters per second, every 25 meters of pipe would have a friction head loss of 1.22 meters. Dividing our total equivalent pipe length by 25 and multiplying it by the value for our friction head loss per 25 meters of pipe length will give us the total friction head for our system. For example, if our total equipment pipe length was 100 meters, for a 101.6 millimeter diameter pipe with a flow rate of 25 liters per second, for our 100 meter pipe length, we would have 100 meters divided by 25 meters times 1.22, which would be our friction loss per 25 meters of pipe. That would give us a total friction head loss of 4.88 meters for that system. We will look at this more closely in an example. The friction head for fittings is measured in equivalent length of piping. Adding the equivalent value in length of piping for fittings to the length of the piping proper gives the total equivalent length of piping for the system. Dividing the total equivalent length of piping in the system by 25 meters and multiplying the result by the friction head for 25 meters of pipe length as shown in Table 1 will give us the total friction head for the pipe and fittings in our piping system. Example 2. 100 meters of Schedule 40 steel pipe having a diameter of 101.6 millimeters and a flow rate of 75 liters per second has 2 gate valves and 1 standard elbow. What is the equivalent friction head? Alright, we have 100 meters of Schedule 40 steel pipe having a diameter of 101.6 millimeters and a flow rate of 75 liters per second. We have 2 gate valves and 1 standard elbow, and we want to know what is the equivalent friction head. Step 1. We find the equivalent length of piping, including the pipe and fittings, using Table 2. And to do this, we're going to make up a working table, and we are going to list all the items we have in our piping system. So we have 100 meters of pipe, we have 2 gate valves, and 1 elbow, and we have a pipe diameter of 101.6 millimeters. So we're going to find the total equivalent pipe length. So we will put down the number of each item we have. For the gate valves, we have 2, and for the standard elbow, which is 90 degrees, we have 1. Then we go down to Table 2 and we find the equivalent pipe length per unit. So we have 101.6 millimeters piping. For a standard elbow, we have 3.35 equivalent meters of pipe length. Going over here, we go over to the gate valve, and for each gate valve, we have 0.7 meters of equivalent pipe length. So we go up here and we put those in their respective column. For the gate valve, 0.7 meters. For an elbow, 3.35 meters per each item. So we have 2 gate valves, equivalent pipe length per 1.7, so 0.7 times 2 gives us equivalent pipe length for the 2 gate valves of 1.4 meters. We have 1 elbow, which equivalent pipe length per unit 3.35 meters, so we have a total equivalent pipe length for the elbow of 3.35 meters. Adding up all our fittings to our actual pipe length, we get a total equivalent pipe length of 104.75 meters, which basically tells us that our system with 100 meters of straight pipe with the gate valves and the elbow would have the same friction loss as 104.75 meters of straight pipe without any fittings. Okay, we take our total equivalent pipe length and we go to Table 1. And in Table 1, we find, using our flow rate and our diameter size, our diameter size was 101.6 millimeters, and our flow rate was 75 liters per second. We see that every 25 meters length of pipe gives us a friction head loss of 12.6 meters. So, from the table, we see 101.6 millimeters of pipe at a flow rate of 75 liters per second. Every 25 meters of pipe gives us a friction loss of 12.6 meters of head. Since we have an equivalent length of 104.75 meters, our friction head is 104.75, which is of total equivalent pipe length, 12 times 12.6 meters of friction loss per 25 meters of pipe length, divide by 25. So our friction head is 52.8 meters. It should be noticed that in Step 1, we are finding the equivalent length of pipe in meters, not the friction head in meters. In Step 2, we are finding the friction head in meters. The friction head is the pressure loss in the pumping system caused by friction and converted to meters of liquid head.